Hey there guys, at this point you probably realize there's a sub today. So today, instead of having a live back and forth type of lesson, we're going to have video notes lesson. You're still expected to understand all the material from chapter 4.3, but we will go over some of it next class in case you guys have questions. Now getting right into it so the video isn't too long, chapter 4.3 covers equations of straight lines and different forms of these equations. So we're we're only focusing right now with linear equations. Now we have three main forms of linear equation formulas. Gradient intercept form, which, remember, gradient just means slope, so this is your slope intercept form. Gradient intercept form, which is y equals mx plus b, where m is the gradient of the line and b is the y-intercept of the line. Point gradient form, which, remember, that's point slope form, which you probably see as y minus y1 equals m x minus x1. It's a little bit cut off, where m is the gradient and any given point they give you is denoted by x1 comma y1. We also have standard form, which is the least used one or the least common one, which is in the form of ax plus by plus c equals 0. We also call this general form. Usually we use this form if we want to find y-intercepts, but it's not very commonly used. Talking about intercepts, we have two main forms of intercepts for linear equations, which are x-intercepts, where the y-coordinate is always 0, where your line touches the x-axis, and your y-intercepts, where the x-coordinate is always 0, and where your line touches the y-axis. You also have two different forms of lines, so you have a horizontal line, which is always in the equation form y equals c, where c is a constant, so y equals 3, y equals 4, y equals negative 1. We also have vertical lines, denoted by the equation x equals c, where c is once again just a constant. So x equals negative 1, x equals positive 1, so on and so forth. So this is some general forms. I went over it really quickly. I do suggest writing it down. We'll go back to these equations, which is why I went through it pretty quickly, also to keep the video relatively short. Also, don't forget, anytime you see gradient or anytime I say gradient, it means slope. This is the last time I'll be saying slope for the rest of the video. So be aware of what I mean when I say gradient. Now, in point gradient form, find the equation of the line that has gradient 3 and passes through point A, or A, which is 1, 7. A few important things to note. First off, they specifically tell us in what form our final answer should be. And we look up here, point gradient form is denoted here, where it's like y minus y1 equals m, parentheses x minus x1. So I know my final answer needs to be in this form. So I'll keep that in mind. So what information do they give me? Well, they tell me that my gradient is 3 and it passes through point A1, 7. They give me a gradient, they give me a point. I can solve it using point gradient form, which is very convenient because my answer is in point gradient form anyways. So y minus y1 equals m x minus x1, and I know my gradient m, and I know my point x1, y1. Now you don't play anything for x and y, this will just be kind of placeholders for any input and output values of our equations, so we'll leave those alone. So the ones I highlighted in pink are the only values you're substituting in. So we have y minus my y1, which remember we write points as x comma y, so my y1 is 7, equals m, my gradient, which they told me was 3, parentheses x minus x1, which my point A is 1. So you'll notice at this point, you're done. It's in point gradient form. You don't have to do anything else. You know you have your equation in point gradient form when you just have an x and y and the point is filled in and the gradient filled in. So we'll move on to part B. So for part B, we are asked, you can probably tell I put a cut there, so ignore that. So in part B, you'll notice it asks that there is a point A, 1, 3, and a second point B, 2, 5. Now in this case, it gives us 2 points, but they don't give us a gradient. That's fine because in the previous chapter, chapter 4.2, we found how to find the gradient between 2 points. That was the slope formula, which, if you don't remember, is m equals y2 minus y1 over x2 minus x1, where the values of all these numbers come from. x1, y1, your first set of points, and then x2, y2, your second set of points. So here, our first value we're going to plug in y2, which we can see is 5. So, let's plug everything in. 5 minus my y1, which is 3. Then I have x2, 2, minus my x1, 1. And this will give me 5 minus 3, which is 2, 2 minus 1, which is 1, so over 1, which I can just simplify to 2. So my gradient is 2. Now, since I have a gradient and I have 2 points to choose from, I can use point gradient form. Now in this case, I have 2 points. I'm not going to use both points. For point gradient form, you only need 1 point. The only time you need 2 points is if you're not given a gradient and you have to find the gradient from those 2 points. Now it doesn't really matter which point you use. I'm just going to use point A because it's the first point I see, but if you had used point B, you would get a correct answer as well. It'd still be the same. So let's solve it. I have y minus y1, which in this case I am denoting by 3, equals my m, which I found to be 2, parentheses, x minus x1, and my x1 I denote to be 1. So once again, these values came from the gradient I found here, so that's the 2 I plug in here, using point gradient form. My y1, I use this value here, and my y2, or my x1, I use from this value here. And once again, you're done. This is in point gradient form. Now, if you had used point B for point gradient form, you would have gotten a different answer. It would be y minus 5 equals 2 parentheses x minus 2, which might be confusing because it looks like it gives you 2 different answers. But if you turn both of those answers into a line, so you graph both of them, you'll notice you get the exact same line, and that's because at their base, if you turn them both into gradient intercept form, then they're the same line. But that's something you'll see in a bit. So we're going to example 2. We have 2 points again lying on a straight line of 2 plots of lines, or 2 plots of land. And we're asked to write the equation of the line passing through points A and B. We have a tree that's located at point C, which is 25, 30. And we're asked to determine whether the tree is on the boundary line. So there's a lot of information they give us, and as well as a diagram, so we kind of break it down. They tell us that points A and B, which you can kind of see here, it's kind of hard to see, lie on the straight line of a boundary between 2 plots of land. So here's one of the plots of land before here, and one of the other plots of land after here. And we want to find the equation of the line passing points A and B. So we want to find the equation of this blue line. Now a tree is located at point 2530. Notice 2530, I can't just plot onto this graph. It's somewhere where it's not plotted. But algebraically, we can determine whether the tree is on the boundary line. So whether the tree lies on this boundary or if it's in one of the plots or the other plot. So let's get started. First, we want to find the equation of the line. If we find the equation of the line, then we can determine whether or not the tree is located on the boundary line. So there's a few different things you can do. Since you're given 2 points, similar to part B in example 1, you can use point gradient form. That's what I'll use here. But you could have also used intercept or slope intercept. So gradient intercept. You could have used gradient intercept since we're given the y-intercept. In fact, I think that one's going to be easier, so I'm going to do it that way. So y equals mx plus b. Once again, you could have used either formula, point gradient form or gradient intercept form. I'm going to use gradient intercept form because I know my gradient here and I can figure out my slope using rise over run. So y equals, or my slope, my rise from point A to point B is up 1, and my run from point A to point B is over 3. So my slope is 1/3. Up 1 over 3, which makes sense. I could have done it here too. Up 1 over 1, 2, 3. So it's 1/3 plus my y-intercept, which is 6. So this is my line. y equals 1/3 x plus 6. Once again, you could have used point gradient form, figured out the coordinates of a and b. So a would have been 6, 8, and b would have been 12, 10, and then just mathematically or algebraically figured out the slope from those 2 points, or just looked at the rise of a run, and you would have had the equation. Now you need equation, whether you use this equation or this other equation, they'll still give the same answer. We need to figure out if point C lies on this boundary line. To do that, what you do is you plug point C into your equation. If it gives you a true statement, then yes, it lies on the boundary line. If it gives you a false statement, it does not lie on the boundary line. And we'll see what true and false statements look like. So let's move on to the next part. So, point C is written in the form, and all points are written in the form of x, y. So if I plug this into my formula I just found here, y is going to be 30, so y equals m, which is still the 1/3, my rise over run, x, which I find from point C, plus b, which I found to be 6, my y-intercept. Now we don't have any variables, so we're just going to solve it from here. So 30 equals 25 over 3, plus 6, which equals 25 over 3. At this point, you can turn 25 over 3 into a decimal. You can probably tell that 25 is not divisible by 3, so it's a fractional answer. And a fractional answer plus 6 is not going to give you a whole number 30, so at this point you say no, it does not lie on the boundary line. Or you can finish solving it, so let's see if I can pull up my calculator. You'll see it cut because I have to pause it so it can load. So with my calculator finally loaded, 3, your Inspire calculators always give you decimal answers as fractions, but if you do control enter, I'll turn to a decimal. So it's about 8.3 repeating. So this obviously does not equal 30. Since this is a false statement, you'll hear my dog in the background. Since this is a false statement, no, the tree does not lie on its boundary line. Now there's other different ways you could have solved it. You already have the equation, so you could graph this on your graphing calculator and see if at point 20, 30, or 25, 30, if that point exists on that line. You could also, knowing the equation, form a table of values on your calculator and then see if at 25 does it give you 30. No matter what method you would have used, you would have figured out that no, this point does not exist on our line, therefore the tree does not lie on the boundary line. Moving on. Example 3. So in example 3, we have a sailing boat that is moving along a straight line with the given equation negative 2.5 x plus y equals 3. And we have to determine whether a tanker located at point A, 3, negative 2 is on the trajectory of the sailing boat. So, in this case, similar to the previous one, we have to figure out does this point lie on the given line. So what you do is you plug in it into the equation, and if it gives you a true statement, such as 20 equals 20, 30 equals 30, then yes, it lies on that line. If, however, it gives you a false statement, like before, where you got 30 equals something that's not 30, like 30 equals 5, then no, it does not lie on the line. But let's actually try it out. So we have negative 20, or negative 2.5, I'll substitute my x in a bit, plus whatever your y is, equals 3. Now, by the way, this is almost a standard form if it was minus 3 equals 0. So remember, ax plus by plus c equals 0. That would be standard form or general form. So that's the form they're giving us. And my point is written in, once again, x, y form, as all points are. So my x is going to be 3, and my y is going to be negative 2. So let's try that out. Now, if you have your calculator, you can do, let's see if I can pull mine up, negative 2.5 times 3, and you would notice that gives you negative 7.5 plus that negative 2. Oh, let me switch screens. There we go. negative 7.5 plus that negative 2, which you can just write as minus 2, equals 3. Negative 7.5 minus 2 is negative 9.5, which does not equal 3, therefore no. The tanker, let me find my charger. So you'll see the video pause. And I'm back. Oh, it's not charging. Let's try that again. Nice. And I'm back with a tablet that will not die on me. So, finishing this problem, no, the tanker is not on the trajectory of the sailing boat. So no. So keep going. Once again, if they had said negative 9.5 equals negative 9.5 or 3 equals 3, then yes, it lies on that line. But since it gives us a false thing at the end, it does not lie on the line. Or, to be more specific, point A does not lie on this given equation of the line. For part B, it says find the exact y coordinate of port arrival time if the boat has the x coordinate 10. This one's really nice because they specifically tell you my x coordinate is 10. Sometimes they'll give you a point and you have to figure out through context clues whether it's the x coordinate or the y coordinate. But regardless, what you do is you just plug it in and see what your output is. So they give us the input 10, we had to figure out our y or our output y. So we're still using the same formula. Negative 2.5x plus y equals 3, except I know my x value. I need to find my y value. So my x value is 10, which is going to give you negative 25 plus y equals 3. You add 25 to both sides. So y equals 28. So that's all pretty simple so far. Example 4, I'll try to go a little bit faster. I know the video is already getting up to that 20-minute mark. Once again, feel free to skip around if you need to. Put me on 1.5 speed, 2 times speed. So anyways, for example 4, we have a Sears work planner who works on designing T-slopes who is finding equations of the following slopes in forms of straight lines, or in the form of straight lines. So we have a slope of gradient 4 and passing through the point negative 2, 5. Since I have a point and a gradient, I'm going to use point gradient form. So my gradient is 4, and I have point this. So y minus y1 equals m, x minus x1, which once again is point gradient form. But I know my y1, I know my slope, I know my x1. That's going to give you y minus my y1, which is 5, equals my gradient, which they told me to be 4, parentheses, x minus my x value, which is negative 2. Now the only thing I have to do is simplify it, because I don't like to leave double signs. But I do know that double negative that happened here become positive. So don't leave it as x minus negative 2. It's really x plus 2. And you're done. All you have to do is find the equations of these lines. Same thing here. You're just going to write the equation of the line. So you're given the gradient and the point. So y minus y1, which is my negative 2, equals my gradient, which is 2 over 7. X minus my x1, which is 7. Which I rewrite as y plus 2 equals 2 over 7, x minus 7. Once again, I'm done. Now sometimes you'll have to do extra. They tell you a particular form you have to write it in, but in this one it just wants you to write equations of linear or of straight lines. So you can use any form. And you'll do the same thing over and over for the next example, so I suggest doing these on your own to practice. But the only difference for part C and D is they don't give us a gradient, so we have to figure it out using point slope form, or using the slope formula. So I'm just going to label my points and then plug them in really quick. y2 minus y1 over x2 minus x1. Something here. y2 minus y1
over x2 minus x1. Negative 1, this becomes plus, negative 1/5, negative 2, negative 3, double negatives make positive. So I found my gradients for both of them, so now I can write my equations in point gradient form. So I'm going to use a point. I always like to use the first point. You don't have to. They'll still be correct, considered correct no matter what point you use, or use the first or second one. But you just need one of them from point gradient form. So y minus your y1, which is 1, equals m, which is going to be negative 1/5, x minus x1, which is negative 3. Let me simplify that as y minus 1, negative 1/5, x plus 3. Do the same thing here, y minus y1, which is 0, equals m, which is 2/3, x minus x1, which is 2. This one you can simplify. Y minus 0 is just y. So typically there's a 0 involved and you can just simplify it. Now this one you can see if you distribute your fraction here to 2/3, it'll give you gradient intercept form, where it's y equals mx plus b. But I'll just leave it like this in point slope form, because it is an equation of a line. Alright, example 5. Determine whether this point lies on these equations. Once again, all you do is plug it in to see if it gives you a true statement. So here's my x, here's my y. So negative 5 equals negative. Be careful here. Don't forget, don't think that this negative in front of x stands for that negative 4. If you just plug a 4 in and you just write negative 4 minus sign, it's going to be the incorrect answer, because that's the same thing as just plugging in a positive 4. So I always like to draw parentheses to remind myself, even if there's a negative, I still have to include the negative next to my x value if it has a negative. Minus 9, negative 5 equals negative 4 is just positive 4 minus 9, which does give you negative 5. 4 minus 9 is negative 4. So yes, this point does lie on the line. 5x plus 4y equals 9, and my x is negative 4, and my y is negative 5. Not true. So this one is yes, and this one is no. Because this gives me a true statement, negative 5 does equal negative 5. However, this one gives me a false statement, negative 4 does not equal 9. I'm going a little bit faster. I keep saying that, then I slow down. Anyways, example 6. Frances runs along a straight line with the equation y equals 1/2 x plus 4. She starts at point C and finishes at point D. Find the y-coordinate of C if x equals 6 and the x-coordinate of point D if y equals 9. Same thing as we've done in previous examples. You just plug in either the input to find the output or plug in the output to find the input. So y equals 1/2. They give me x, so I'm going to plug it in here. X plus 4. And they told me x equals 6. I'm plug in 6. Y equals 1/2 of 6 is 3 plus 4. Therefore, y equals 7. For the next one, I'm going to plug in my y because they give me y. So they tell me y equals 9. So 9 equals 1/2 x plus 4. I need to find x. So I go, remember backwards from this, we're undoing things. So subtract 4 from both sides. 5 equals 1/2 x. Multiply by 2 on both sides, since 1/2 is just divided by 2. Or 1/2 times 2 is 1, which cancels out. And then 5 times 2 is 10. And you're done. X equals 10. So those are relatively straightforward. Example 7, in gradient intercept form, find the equation of the line with gradient -2 and passing through
this, so they're very specific once again. This one wants to be in gradient intercept form, so this is different than example 1. Remember, gradient intercept form is y equals mx plus b. So that's what our lines have to look like. So in gradient intercept form, find the equations of y. Now, although they wanted it in gradient intercept form, they don't give us the information we need for gradient intercept form. I just realized my charger, or my thing's not charging. Oh wow. Do I have to know? Oh. What if, I need to pause. Okay, it's finally charging. So, as I was saying, they give us gradient and they give us a point, so we can use gradient intercept form, or not gradient intercept form, gradient point gradient form, but then you will have to change it into gradient intercept form. So you could use a y minus y1 equals m x minus x1, and then once you get it, transfer it into gradient intercept form, or you can just plug everything into gradient intercept form and solve for your y-intercept. Probably sounds confusing, so I'm going to solve them, both of them, in two different manners, in the two different suggestions I gave you guys. So the first one is just solving it using point gradient form, because we're given a gradient and a point. So y minus y1, which is 3, equals m, which is at negative 2, x minus x1, which is at negative 4. Simplify, that should become y minus 3 equals negative 2x plus 4, but remember we want it in gradient intercept form. So let me give myself more space. To do that, I'm going to distribute out that negative 2 and keep this the same. So after distributing that negative 2 is y minus 3 equals negative 2x minus 8. This negative 2 times x is negative 2x, negative 2 times 4 is negative 8. Then, for gradient intercept form, I know I want to have y by itself. So, I'm going to add 3 to both sides. And now we can y equals negative 2x minus 5. And now, notice it's in gradient intercept form. I keep having to remind myself it's gradient, not slope. So you're done. So same thing as you did before, you're just converting to a different form. Something else you can do, and whichever method you use, whether method I use in part A or part B, doesn't matter, you'll get the same answer regardless. But I do want to show you two different ways you can do it. Now for part B, it's the same thing as part A, except slightly different. They don't give you the gradient. But at this point, we know how to find gradients. Using my gradient formula. So I'm going to label my points, and then plug it into this formula. My y1 is negative 1, x2 is 6, x1 is negative 2. That becomes plus because there's double negative, so negative 5 plus 1 is negative 4. 6 plus 2, the pluses, 6 plus 2 is 8. It's negative 1/2. So, the second method is, I want to show you the second method? Yeah. The second method is using the form they want you to find it in directly, and then just plugging in values. So let's say I want to use this for my x and y. So my y is going to be negative 1 equals, I know my slope is negative 1/2. My x is at negative 2 plus b. The only thing I don't know is b, my intercept, for gradient intercept form, but I can solve for it. It's going to be negative 1 equals, or negative 1/2 times negative 2 is positive 1 plus b, and then you get b by itself. I subtract 1 from both sides,
b equals -2. So I can rewrite my formula, where now I know b, so I can plug that in, and I know m. So y equals -1/2 x plus b, but since it's a negative number, I'll write as -2. So that's the second method. If you had used the same method we did in part A, so use point gradient form, you would get the exact same answer. Either method works. So I could have used this method for part A or use this method for part B. Doesn't matter. Like I said, those are just two suggestions you can use. Alright. I know the video is long. Keep in mind that usually lessons are 80 minutes, so that's why the video is so long. Example 8. We have a country road with equations y equals -7, I believe that should be 0.5, plus 11.5. Let me check. This is a typo. Alright, so it was a typo. So, our equation is y equals -0.75x plus 11.5, which intersects two state highways with equations x equals 0 and y equals 0. So those are just your axes. A beverage shop owner wants to open two new shops exactly at the intersections of the country roads on the state highway. So he wants to plant some shops at the y-intercept and the x-intercept. So we have to find the exact locations of the two beverage shops. So you need to find the x and the y-intercepts. So first off, to find x-intercepts, remember this means y is always 0. So I'm going to take my equation, except I'm going to make y equal 0. -0.75 x plus 11.5. Then I just solve for x. So that's going to give me -11.5 equals -0.75x divided by 7.5. So let's get my calculator. So we have -11.5 divided by -0.75. This is about 15.3 repeating. Or you could just leave it as a fraction. Let's switch back. We'll do the exact same thing. My y-intercept, the only difference is for y-intercept, x's are zeros. So this time, the 0 I'm plugging in is going to be my x. 0 times anything is 0, so this just gets canceled out to be 0. You get y equals 11.5, and that one was easily solved. So those are where the two shops will be located. Now, they say find the distance between these beverage shops. So we are going to use the distance formula. Now, this is really x-intercept, and this is really my y-intercept. So really, my points are 15.3 repeating, 0, and 0, 11.5. So let's call this point A and point B. Distance formula is x2 minus x1 squared plus y2 minus y1 squared. So this is going to be 15.3 repeating plus 0 squared. I should give myself my face. Or, whoops, minus. And then 0 minus 11.5 squared. Now in my calculator, I'm not going to use a rounded value. Remember, don't use rounded values until the end. That leads to rounding error. I'm still going to use the value. So, let me show you how to do that. So, here's my square root, parentheses. I want to use this value, so I'm going to do control. And you see the negative sign where you see kind of an answer on top of it? Answer.
So it's going to use this one, the repeating value. So not just a rounded 15.3. Anyways, you'll do that. You can do minus 0, but you know anything minus 0 is itself. I'll put it in just for the equation, but you really didn't have to. And then 0 minus, once again, this would just be negative 11.5. 0, anything minus 0 is itself. So that gives you about 19.167 or 1.19.1667, which if we're running 236 base is 19.2. Cool. Example 9. Two straight rows have equations y equals 3x plus 15 and y equals negative 2x plus 5. A traffic light has to be installed at the intersection of the points. Find the coordinates of the intersection of the points of the two roads. So to find intersection of lines, we know intersections are the point at which two lines meet. When you think about the roads, if you drive, intersections are usually where two roads will meet, and it's kind of the middle part. So to figure out where these two lines meet, well, for them to meet, they're going to have an equal point. So that if they share a point, then that's their intersection. So what you do to find intersections is make them equal to each other. So 3x plus 15 equals negative 2x plus 5, and then you solve for x. So, there's a lot of different things we can do. I'm just going to get all my variables to the left side. 5x plus 15 equals 5, and then give my constants to the right. 5x equals negative 10. Divide by 5 on both sides. X equals negative 2. So notice it says find the coordinates. I found the x coordinate, but coordinate points have 2 points, x, y. To find the y spot, I need to plug in my x coordinate I found to either equation. It doesn't matter what equation I plug it into, it can do the same thing. I'll plug it into the first one. Please remember, we have the input. If I put in the input, I'll get the output. So what happens at point negative 2? Negative 6 plus 15, y equals 9. So my coordinate point is negative 2, 9. Which makes sense. If you had used the other one, you would have had negative 2 times negative 2, which is positive 4. 4 plus 5 is 9, so you still get the y coordinate 9. So once again, it doesn't matter which equation you use, they'll still give you the same y coordinate, which makes sense because it's the intersection. So they share a point. They have the same x coordinate, same y coordinate. So that's my answer. So going on to example 10, Bike and Bloom sells flower bouquets. The equation modeling the total cost of making the number of bouquets they make is C equals 600 plus 72x, where C is given in the Danish krona DKK. So similar to USD or things like that, it's just the abbreviation of the currency. Find the gradient of the line representing this equation. Well, the gradient of the line, we know this one is in gradient intercept form. My gradient, is the number touching x. The number touching x is at 72. Now let me make sure there's no typo because the formatting got a bit off. The good news is not much of a typo. The only thing that's missing is that 6,000. So anyways, 72 is my gradient because it's the number touching x. And then we have to interpret the meaning of the gradient. So in this case, if x represents the number of bouquets they're selling, then the gradient is how much each bouquet costs. Is that a bouquet? Nice. Because you do the price times the number of bouquets that are being sold. And that makes sense because they're going to be real cost. Now, determine the y-intercept. So in this case, since it's in gradient intercept form, well, the intercept is the number without the x. So, the 6,000. And if we're interpreting what this means is, there's a base cost of 6,000 that goes into the total cost. So that might just be how much a company that you're buying from charges you. This is a flat rate. And then you have the extra $72 for each bouquet you sell, or each bouquet you make. So that's just a flat rate. No matter what, even if you don't sell any bouquets or you don't order any bouquets, you always have to pay that $6,000. Now, could the total cost per month be zero if no bouquets are made? Well, we should kind of talk about this. No. Because you always have starting costs. So if you think about it, if you sell 0 bouquets, then that's going to be 0 times 72, but you're still left with that 6,000 in the equation. So it's never 0. You always have to pay, which is the reality in business. Even if you don't sell anything or if you don't order anything, usually you're still costing to pay. Part E, find the number of bouquets made if the cost is this much. So what you would do here is, I kind of mentioned this before, they don't tell us if we're looking for the x-intercept or y-intercept, and they don't tell us if the value we give us is the x or y-intercept. So you kind of have to reason through the context. So find the number of bouquets made. Well, I know the number of bouquets made is x. If the cost is this, y know cost is my output, my y. So in this case, they're telling me y equals this much, find x. I'm not going to solve this. I would suggest you try and solve it on your own. You would just plug in this y value to the equation they give you to solve for x and kind of work backwards until you can find x. And that's just your answer. But let me go a little bit faster. So we're almost done. I believe there's okay, let me go a little bit faster. There's more examples than I thought. So we have this town that only has 50 social housing units where the new when the new social program started. Since then, it has added new social housing at a rate of, or at a steady rate. 17 years later, the town has a total of 322 social housing units. So we have to find the rate of increase in social housing per year. Now, anytime you see rate of increase or anything like per, you know you're talking about gradient, not slope. Gradient. And so they don't give us the equation of this line. We kind of have to figure it out. Now, something we know is that 17 years later, we have 322 social housing units. And at the 0 year, when we're first, kind of marking our time, we only have 50. So we have 2 points, 0, 50, and then 17 years after the social program, 322. So since we have 2 points, we can find the gradient. That's just the gradient formula. So y equals y2 minus y1 over x2 minus x1 12, 2, 3, 7, 2. So let's put that into our calculator. And we get 16. Nice. It's an even number. I think it was 16. I already forgot it. So 16. So this is my rate of increase. This is also your gradient m. So 16 housing units per year are being created. Now we have to write an equation for the total number of housing units represented by variable h that the town has in relation to the number of years using variable x that have passed since the program started. By the way, that's how they write program in English. No, what is it called? British English. There's ending at the end. So that just is program. So y equals mx plus b. I know m. I just found it. So 16 x. Now you have to be careful for b. You don't have to solve for B. You already know B. Remember, B, your y-intercept, is always the starting value of your line, of your graph, of your context. We know how many housing units we had to start with. Right here. It only had 50 housing units at the start of the social program. So you have to be very, very careful when writing equations of lines, especially when there are these word problems where you kind of have to think through them and think what everything means and where everything goes. So you didn't have to do any math here. You just had to understand the problem. So we have an equation to work with. So my questions are going to get harder because I don't have an equation. So determine the gradient of the line and interpret its meaning. Oh, never mind. My gradient, and I kind of already talked about it, is 16. And I already talked about what this means is 16 housing units are made or built per year. Determine the y-intercept in this meeting. We already found the y-intercept is 50 housing units were already made at the start of the program. Which makes sense. The program didn't create all the housing units. There was already 50 housing units. The program just allowed them to create more housing units at a stated rate. So determine how many housing units are in the town after 13 years after starting the program. So this is similar to before where I said they don't necessarily tell you what is the x-coordinate and what is your y-coordinate. You kind of have to figure out in the context of the problem. So in the context of the problem, you kind of have to figure out what your input it is and what your output or what your independent and dependent variable are. So you ask yourself, okay, what depends on what? Well, the amount of housing units depends on the amount of years. Because after 1 year, well, that will cause more to be built. And in 2 years, it will cause more to be built. And it makes sense in the sense of our equation. If we look at our equation, y equals 16x plus 50, it's 16 housing units per year. So x represents years. So in our problem, they're telling us, figure out how many social housing units will be made after 13 years. Well, if it's 16 per year, once again, x is your years, so x equals 13. We want to figure out how many outputs or how many housing units we have at the end of that 13th year. So similar to for previous problems, we're just plugging it in. We don't know y. However, we do know x. So we're going to do 16 times 13. We'll wait. We're going to add 50 to that, so 250. Cool. Oh, let me switch. So, there we go. After your 13th year, you'll have 258 housing units built with the program. Part D is telling you to do the same thing, produce the number of social housing units after 22 years. So here we know it's going to be a larger amount. Because my x is larger, therefore my output's going to be larger. Oh, whoops. I don't know why. There you go. I'll let you guys solve this one on your own. This is that same thing as part E. Now part D is similar, but it is slightly different. In this case, they want you to find the year given the social housing unit. So you know the output. You need to find the input, how many years it took to get there. So 200 housing units. So I know my output 200. I want to figure out what my input was. How many years did it take to get there? So 200 equals 16, I don't know, x plus 50. 150 equals 16x. Divide by 16. X equals
150 divided by 16. Oops, enter. And turn into a decimal. About 9.375. Now you don't really want to say it takes 9.375 years. You actually want to round up, because you don't really want to say it takes 9.3. Like I said, that's an odd way of saying how many years it took. So it really took 10 years to get to that 200 special housing units, because we're going by home and residence. Example 12, you need to find x and y intercepts of the given line. So this is where you either plug in 0 for x or plug in 0 for y and solve. So I'll do one of them and then you guys can do the rest of them, so I can finish out this video because it's getting pretty long and I still have a few problems to go through. So y-intercept, oh whoops, I was so fast. X-intercept means y is 0. Y-intercept means x is 0. So x-intercept y is 0, so 0 equals 5x. So x equals 0. And then x equals 0 to find y-intercept. This one's a lucky case. It was kind of an easy one. And you probably could have figured it out without actually solving it on paper. You probably figured it out in your head. But my x and y-intercepts for y equals 5x is 0 for your x-intercept and 0 for your y-intercept. You'll do the exact same things for the next ones, even though they're in different forms. So part B is still in gradient intercept form. However, part C is in a variation in standard form. Still solve it the same way. For part 13, there's an air traffic control, which has 4 flight rounds, represented by straight lines given in A through B below. So here are my 4 flight lines, A through B. A, B, and C, they just give you the equation. Part B, you have to find the equation for the 4th flight line, so we're going to start there. A line with gradient 2 and passing through the point -130. So in this case, it doesn't really matter what form you write it in. They're not specified. They're all different too. Part A is in point gradient form. Part B is in gradient intercept form. Part C is in standard form. So you can put it in any form. I usually prefer to have things in gradient intercept form just because it's easier. Your work is going to fit me. But in this case, they give us a gradient and a point, so we can use point gradient form. Like I said, it doesn't really matter. I just leave it actually in point gradient form so I don't have to change it around. I just solve it. So y minus my y1, which is at 3, equals m, which is at 2, x minus your x1, which is at -1, and if I simplify it, it's y minus 3 equals 2x plus 1. So now I have my 4 equations of the lines of the 4 flight paths. So, part E, determine the x and y intercepts of route A. So route A is y minus 1 equals -1, x plus 4. My x-intercept is where y equals 0. So let's find that one first. 0 minus 1 equals -1, x plus 4. So, -1 equals -x minus 4. Add 4 to both sides. This one gives me 3 equals -x equals -3. Kind of did that a bit quickly. Hopefully you saw what I did. I just plugged in 0 for y. That's the only thing you have to plug in if you want to find x. So 0 minus 1 is -1. I distributed that -1. -1 times x is -x. -1 times +4 is -4. I added 4 both sides so I can cancel out that 4. 4 minus 1 is 3.
3 equals negative x, divide by negative 1 on both sides, x equals negative 3. So my x-intercept is negative 3. And to find your y-intercept, that's when x equals 0. So y minus 1 equals negative 1, x equals 0, plus 4, which equals negative 1 times 4, y minus 1, negative 4, y minus 1, y equals negative 3. So you add 1 to both sides. Now technically, there's better ways of writing the answers. You would say x-intercept equals negative 3, not just x equals negative 3. And then y-intercept equals negative 3 because it's not just y, it's the intercept. Or you'll write them as points, so negative 3, 0 for the x-intercept and 0, negative 3 for your y-intercept. So they're different points, so be careful there. The intersection of points of my route A and B, so we kind of did this before. You make them equal to each other. Now to make them equal to each other, you have to be careful. I'll write it down first, then I'll show you. Okay. So this is route A and route B. Y equals 2.5x. Okay. You can't just make them equal to each other in this case with the equal sign, because you do y minus 1 is equal to this. It's not the same thing. Before we can make them equal, so they were both in the same form, where they're both, it was y equals this and y equals this. So since they shared a y, that's why I made them equal at that point. But here they're different forms. So for me to make them equal to each other and find the intercept, I have to put them in the same form. It's easier to put them in gradient intercept form. So that's what I'm going to do. I'm going to change part A. Part B is fine. It's already in gradient intercept form. But part A isn't. So let's see. Y equals negative 1. X plus 4 plus 1. I just added the 1 from here to this side, which is negative x times 4 plus 1, which is that. Okay. Y equals negative x minus 3. So all I did was make it so that they're in a similar form. And to do that, I just added 1 to both sides to get y by itself, distributed the negative 1, and then I had these two like terms, the negative 4 plus 1, which became negative 3. So now, since they're both y equals, now I can set them equal to each other. 0.5x plus 3 is equal to negative x minus 3. Add x to both sides. We can do 1.5x plus 3 equals negative 3. Subtract it from both sides. Get rid of that. 1.5x is negative 6. Divide by 1.5. X equals negative 4. But that's not your final answer, because you want the intersection point. You found the x coordinate, you found the y coordinate. So to find the y coordinate, let's see if I can find it. You just plug it in. So I'll plug it into the easier one, which is my second equation here. So y equals negative 4 minus 3. Negative 4 is positive 4. Y equals 1, so my point of intersection is negative 4, 1. You could have also just graphed the two lines on your graphing calculator and found the point of intersection, which would still be negative 4, 1. Part G, which is the last part, says show the routes C and D have the same y-intercept. So, what you do here is part C is in standard form, so you want to put it in gradient intercept form. And then D is in point gradient form when I wrote it, so you have to put it also in gradient-intercept form, so they both have the same intercept, so the same b-value. So you could also, which might be easier, we know for y-intercepts is when x equals 0. You could also plug in 0 for x and then find your y-intercept that way. So those are two options. Either change the form of both of them so that they're gradient-intercept form, so that to show that they have the same b-value, or what I think I'm going to do is the second way, which is just find the y-intercept of both of them. So C equation is 2x plus y minus 5 equals 0, with the standard form. 2x plus y minus 5 equals 0. And then b was y minus 3. 2x plus 1. So I'm going to plug in 0 for x to find my y-intercept. So if that makes the 0, we get y minus 5 equals 0. Y-intercept is 5. We should add 5 to both sides. So this one have a y-intercept of 5. So y minus 3 equals 2. My x is 0. It's going to be 2. Add 3 to both sides. Yeah. We both have a y-intercept of 5. Hopefully you saw what I did there. If not, do it on your own paper to see. So what I'll say, this video is going pretty long. It's already into the hour mark. There are 2 more examples. I would say do these examples for homework as well as your Delta Math. I'll make the Delta Math shorter this time. But do it for homework and we'll discuss it next class. So look at the Word document. If not, just pause the video. Here's example 14. And I don't know if the video is covering it a bit, so let's see if I can get it to disappear. And then here's example 15. And let's see if I can get my video to disappear. Maybe not. Okay. I'll stop there. Try those on your own, see if you can solve them. I'm going down slowly so you can read it. I've included the Word document so you can just look at it that way or just pause the video. So try these two on your own as homework. If you have questions, feel free to email me. If you still have some questions over any of these examples, even the ones I go over in the video, let me know and we can go over it at the start of the next class. See you guys next class.